Welcome back everybody to another video lecture from Mrs. Semino. In today's video, we're going to be focusing on how to write ionic compounds using polyatomic ions. It's really going to be the same procedure that we used for the binary ionic compounds up here. It's just that the polyatomic ions are a little bit larger, and I'll give you a better definition. But before we move on, I just want to do a quick review. So remember when we talk about an ionic compound, that ionic compound is going to be made up of a metal and a nonmetal. And then when we go to write the formula for these, we want to make sure that the cation, the positive charge, is balancing out the negative charge. So for example, if we had calcium, and if you look on your periodic table, you'd see that calcium has a 2 plus charge. If we had bromine, you'd look on your periodic table and see that it has a 1 minus charge. So if we were to add up the cation charge and the anion charge, you're going to see that those are not the same values, okay? The idea here is that we want them to add up to equal 0, right? Because we want our compound to be neutral. Well, how could we get them to add up to 0? I could add another bromine here. That would make this be a -2 charge, and now +2 minus, oops, that's not what I wanted to do. -2 will equal 0. And then so when we go to write the formula for this, this would be Ca, because there was only one calcium we used. And then notice we had two bromines, and so that's why I'm going to write Br2 here. Okay, so now what is a polyatomic ion? If we just look at the word, we can use some of like the clues here. Poly means many, atom is atomic here, it means atom. So there's going to be many atoms that are together that have an ion, that are an ion. Remember, and they have a positive or a negative charge. So here's our formal definition. A group of atoms that are covalently bonded to each other. Okay, that's kind of weird, right? They're covalently bonded, and they've lost or gained electrons to become a more stable molecule. So if we look down here, we can see, like in this first example, we've got nitrogen and then 4 hydrogens, and it has a +1 charge. So we've got 2 different elements that are covalently bound and that they have a charge associated with it. And you can see that we have some other examples down here too. So this first one is ammonium. Ammonium is really the only positive polyatomic ion that we're going to run into, so it's kind of special. But then these other ones, you're actually probably pretty familiar hearing these names before. So CO3 with a 2 minus charge is a carbonate ion. NO3 with a 1 minus charge is a nitrite ion. PO3 3 minus is a phosphite ion. And there's actually a bunch more on your polyatomic ion sheet. So you don't really need to like write these down right now. Just look at your polyatomic ion sheet to see all that are there. So now when we want to write the formula for these polyatomic ions, I'm hoping that you're going to notice it's the same way that I explained on the first slide, where we want the cation and the anion charge to be the same, but with an opposite, how do I want to say it? The same number, but an opposite charge. So for example here, this would be sodium nitrate, okay? And how did we write this? How did we get this formula here? Well, hopefully you remember that sodium has a 1 plus charge. Nitrate, if you look at this one, and notice how I said nitrate. On the last slide, I said nitrite. Depending on the suffix of the polyatomic ion will determine the number of oxygens. So this one has 3 oxygens. On the last slide, it only had 2 oxygens, so that's why I said nitrite before, but this one's nitrate. And we'll get into that in a minute. But the idea here is we've got one positive charge, one negative charge. And so those charges are balancing each other out. So I just need 1 sodium and 1 nitrate. On the other hand, when we look here, we've got sodium, again, still with its 1 plus, but now we have a different polyatomic ion, and this one's called sulfate. Notice how it has a 2 minus charge. So if you look at these 2 charges, they're not balancing each other out, so we would need 2 sodiums, right? So we can have a 2 plus charge here. So this would, now we don't want to write these charges when we're writing our formulas. I'm just trying to write them in so you can see. So we'd have 2 plus because there's 2 sodiums, and then of course the -2 from the sulfate there, okay? Then if we can do the same thing here, sodium again has its 1 plus charge, phosphate has a -3 charge, so we would need 3 of those sodiums to balance out the 3 negative charge in the phosphate ion, okay? Then over here you can see another example. This time we're using calcium, and calcium, as I showed you before, has a 2 plus charge. But now if we bond the calcium with the nitrate ion, notice that we would need 2 of them. And so this is kind of a little different. and something that kids kind of forget to do, is I wouldn't want to write CaNO3 like this, because doesn't it look like there's 32 oxygens there? And there's really not. So when I put the parentheses in, we kind of treat it like a distributive property in math. So this would be 2 times 3, so that would be 6 oxygens here, and then 2 times 1, because there's like an assumed 1 there, so we'd have 2 nitrogens. So this parentheses with this 2 on the outside says that there's 2 of those nitrate ions. And so I could also kind of draw it like this. Let me find some room on here. So I could have a calcium ion, and then I would have like 2 nitrate ions like surrounding it. And so that would be our compound, okay? And then finally, we can see these last 2 examples here. We've got calcium again with the sulfate ion. Those 2 charges this time do balance up, so I just need 1 calcium and 1 sulfate, so no parentheses were needed, okay? Then down here, if we put the calcium with the phosphate, we would need to think of the lowest common denominator of 6 in between those. So we'd need 3 calciums and then 2 of the phosphate ions. So notice this time I'm still using my subscript here for the 3 because I would need 3 of these. And then I would need 2 phosphates, so I'm going to use the parentheses and put the 2 on the outside. So here are a couple of practice problems for you. Go ahead, pause the video, solve them, and then hit play again so you can see the answers. So for the magnesium chlorite here, we would solve that by looking at magnesium has a 2+ charge. The chlorite, sorry, I think I said chlorate a second ago, I meant chlorite, has a 1- charge. So you can see that those charges aren't balancing out, so we would need 2 of the chlorites. So this would be -2 plus 2. So since I needed 2 chlorates, I used a little 2 subscript here. The next one here with strontium phosphate, we've got strontium, it has a 2+ charge. We've got phosphate, 3- charge. Again, if we add up these charges, we're going to see that they're not the same. And so how would we do that? Again, we're going to look for that lowest common multiple between 2 and 3, which would be 6. So I would need 2 more strontiums, and that will make this +6. And then if I add 1 more phosphate here, this would make it -6. And then you can see that those charges are canceling out. And so we need 1, 2, 3. So I put the 3 there, and 2 of the phosphates, and I would put that there. And then you can go ahead and work out the next 2 the same. So hopefully aluminum, you're remembering that aluminum has a 3+ charge. Nitrate, okay, has a 1- charge. So we would need 3 of those nitrates to cancel out the 3 positive charge in the aluminum. And then finally down here, you guys, we have our ammonium, and so that's this guy right here. Ammonium has a 1+ charge. And it just says oxide, so this time we're not bonding it with a polyatomic ion because it already is a polyatomic ion. But ammonium can bond with other polyatomic ions. Just in this example, I did it differently. So oxide would have 2-, so notice how you would need 2 ammoniums here to balance out the charge. Okay, so why the balancing seems kind of complicated and you're like, wow, there's more elements and stuff like that. The naming is actually super easy. So remember when we name ionic compounds, we always keep the first element's name the same. So like this is sodium, so we didn't change it. Okay, sodium again, calcium, didn't change it at all. And then the polyatomic ions, we actually don't change those either. So that's why I said that was pretty simple. So when we go ahead and we look at this polyatomic right here, we're going to see its name is acetate on your polyatomic ion sheet. Go ahead, take a second, look it up. So notice we're not changing the name of the polyatomic ion at all. Here, if we look at sulfate, okay, we can just see that sulfate is, it's the same on the polyatomic ion sheet. And then finally, this one down here is hydroxide, so we just called it calcium hydroxide, okay? Now, I did mention that ammonium is like the only positively charged polyatomic ion. And so again, especially since it appears first, we just leave it as ammonium. So in this case, this guy would be ammonium fluoride here. So notice we did add the IDE because there's only one F there. And then this one, like I said, it can be bonded with other polyatomic ions. So we would have ammonium hydroxide, and you can see we didn't change those names at all. So easy peasy. So now here's a few more practice problems to practice the naming. Go ahead, solve or pause the video, solve them, and come back and check for an answer. Okay, so let's go ahead. Let's see what this answer is here. Okay, so for this first one here, we're going to have lithium and then the OH we saw before, so lithium hydroxide. Here, Ba is barium, so remember we don't change that first name. And then do you see how this one's ClO3? So this is chlorate, so just match that up on your periodic table. So barium chlorate. Here we've got Ag, that's for silver. And then the NO3 is our nitrate, so we're just going to say silver nitrate. And then down here, we've got cesium sulfite. So Cs, I know it's not very common, but you can find it in the first column on your periodic table. Has a 1+ charge. Sulfite has a 2- charge. Oh, I guess we didn't need that because we're naming. Okay, let me focus here. Okay, so cesium, this would just be cesium sulfite. So notice that we're not changing these names at all. Please write down any questions that you have and ask me in class. And just as a reminder, remember a polyatomic ion is a group of atoms that are covalently bonded that have a charge. We're going to use it and balance the chemical equation for ionic compounds the same way. And then the naming is actually incredibly easy. The cation, the first element name stays the same. The second one, if it's a polyatomic ion, also stays the same. So very nice.